screen here and bring up a PowerPoint that I put together. We're going to do a ecology review with. And so we have, this is going to be part one of the review. So there's tomorrow we're going to work on the second half. So we're just going to go through some of the different concepts here so you guys can have more of a chance to kind of grasp some of these concepts prior to taking the test. So there's 24 different topics that I have for the review. So we're going to work on the first 12 today. The first word on your review was producers. And I have a ecological pyramid here. And you can see at the bottom down here, it says producers. And there is significance to the fact that this pyramid gets smaller as you go towards the top of the pyramid. And the bottom, you have the producers. Top, you have the predators. They use quaternary and tertiary. We didn't talk about those two words. You don't have to know them, but you do have to know that nobody is consuming this top predator. That's how it's defined, that you are in this final top predator position, is that you are not eaten in this ecological system. And that's pretty much how the different levels of consumers are defined. We didn't talk about really much about trophic levels either, but as long as you understand that if you are a producer and you are consumed by this first level consumer, okay, that's what defines your position in the ecological pyramid, is if you're consumed and if you do the consuming and who's eating whom in this pyramid. So the higher up you go, the less things that are eating you versus down towards the bottom, the more things that will consume you. Another important point is these producers all make their own food through photosynthesis. They get their energy from the sun. That's important to understand about the producers. All the other consumers, they get their energy from either from the producers or by eating other consumers. So we actually just did the first three questions, or the first three terms, the different levels of the ecological pyramid. Okay, it's defined by what you eat and who eats you, and what your organism eats. Most of you guys were pretty familiar with carnivore, herbivore, and omnivore. Just herbivore eats plants, eats the producers, and the carnivore eats either other consumers. It does not eat any type of plant or producer matter. Omnivore eats both. So an animal that eats both plants and animals is an omnivore. Humans are omnivores. Animals like bears are omnivores. All right, so we'll move to the next slide here. Energy pyramid. So 100% of energy in an ecosystem is down here at the producers. Okay, 100% of the energy is coming from the sun. That's not quite true. There are other potential ways that most of the energy coming in to an ecosystem comes via the sun. We were talking a little bit about vents in the bottom of the oceans, archaeobacteria deriving their energy from sulfides. But then as you go up each different level, as we defined by who eats whom, the first level, they eat the producers. you lose 90% each level that you go up the energy pyramid. So there's actually very little energy left by the time you get to the top consumers. Very little energy, almost, and this is just kind of like a rule of thumb. And if you really think about the size of the Amazon rainforest, and how much, and just the pure mass of the amount of energy that's required to make the producers, by the time you even get to the first level consumers, you've lost a tremendous amount of energy. Okay. Bioaccumulation, biomagnification. Okay, this slide does a nice job of kind of showing you the difference between the two. Bioaccumulation is just the amount of poison that accumulates in an organism, just one organism. Biomagnification is the process of the poison being passed up the food chain. So all the poison that this fish gets is then its entire lifetime, as it feeds, is entirely passed on to the next level of the food chain, so all the little fish that the second fish here consumes is passed, is taken from the first level consumer there, and all the poison that it accumulates goes to this third level of fish, and then up the food chain you go. Say if an eagle eats this fish, all the poison that was ever consumed by this first level is then passed up into this level of the food chain. So that's magnification, and the accumulation is simpler in that it's just the total amount of poison that a fish will, or an organism will accumulate just by eating in an ecosystem. Doesn't necessarily refer to the magnification as it eats other organisms. Okay, so next concept was isle-royal balance in an ecosystem, predator versus prey. So isle-royal was very easy to kind of grasp. You have a population of wolves versus a population of moose, and you can see here the moose, or the darker, and the wolves have the undarkened squares here. And as the moose population rose, or was lower, okay, the wolf population also would rise. But then as the moose population would begin to drop off, eventually the wolf population would then follow. Moose population, as the wolves went down, there was less predators attacking the wolves, so the moose population went up. And then you would have an increase in the wolf population. So you'd have this kind of back and forth, but both populations able to kind of be balanced by the fact that they're both dependent. Obviously the wolf is dependent on the moose, but so it just is just this back and forth kind of relationship between the two species. Predator prey, I think you guys are aware, the wolf is the predator, and the moose would be the prey. Moving on, we have the different types of symbiosis, and we have three different types: mutualism, commensalism, parasitism. Mutualism, here you have both species benefit by the relationship. Commensalism, one species benefits, the other species is not hurt. So the example of the remorse fish kind of tagging along with the shark. Shark's not hurt by the fish. but the shark does not benefit. That's a little tricky. Mutualism, they both benefit. They get here the birds or the bee and the flower. The flower gets its pollen distributed, and the bee gets nectar, and so they both benefit by the relationship. Here, parasitism. You have some type of organism that's does not help but hurts its host. It's who it's kind of latching onto. It's using, and it benefits, but its host does not. So it's a parasitic relationship. Here we have Earth's seasons, okay, and the effect of Earth's tilt on those seasons. So we have a 23.5 degree tilt to, here is this would be vertical right here, 23.5 degree tilt of the Earth's axis. And that, what happens during the course of the year as we make the trip around the sun, the Earth's rays shift daily. Here, this is showing the summertime in the northern hemisphere and the wintertime in the southern hemisphere. And you can see how the rays are coming in directly here into the northern hemisphere, and they are on an angle coming into the southern hemisphere. So it's going to be colder. It's going to be colder down here, and it's going to be hotter up here. And then because this axis doesn't shift, when it reverses in the summertime, in the southern hemisphere, it's going to be winter up here in the northern hemisphere. So the sun rays will come directly in here, and in our winter time, the sun is going to be coming directly into the southern hemisphere, and they will be experiencing summer. So that kind of creates has a big impact on our biomes. Up north in the northern towards the you always get kind of indirect sunlight near the North Pole, and so it never really gets that warm up here, and so you have the tundra. The region just south of the tundra, you have the taiga, which is the tree roots are able to kind of get into the soil, so you do have some conifer, pine needle trees that can survive and are adapted to the cold weather. And then in our latitude here, you can get the deciduous forest, the trees that lose their leaves. And as you get down towards the equator, the regions below 23.5 degrees north latitude and north of 23.5 degrees south latitude, you get the tropical rainforest, tropical or the deserts, depending on the amount of moisture in the biome. So that the Earth's axis has a huge impact on the, especially north and south of the tropics of Capricorn and Cancer, has a huge impact on the type of biome in different regions of the Earth. Desert biomes receive less than 10 inches of rain, and they can be anywhere in the world. They can be high. It can be up north, or they can be in, like, say, the Sahara here, very near the equator. They tend to be near the middle latitudes, but not necessarily. Here we have ecological succession, and the big concept here is that the difference between primary succession and secondary succession. Primary succession, you have rocks. It's the plant life has to, in order for it to grow, has to have some type of soil. So it takes a very long time to kind of develop enough soil so you can grow the say grasses. You can get lichen and moss that can grow with very little soil, but it takes a long time to get into where you'll have secondary succession, or the potential for secondary succession, where you already have soil established. So you have here, you show some type of catastrophe. Typically, if there's a massive forest fire, will burn down the forest, and the secondary succession can kind of take over. Whereas if you say have like a volcanic eruption and you have brand new rock, you have primary succession. The amount of time it takes to go from here out to say where we have here as a climax forest takes a lot longer than if you say just had a forest fire and you already have the soil established. That an ecosystem can bounce back fairly quickly. So that is kind of the in the kind of the nuts and bolts of ecological succession there. So those, we have one more concept here. That was ecological succession. Here we have element cycling. This is carbon. We're going to be focusing on the two. You guys are pretty much aware of how water evaporates, condensates, precipitates. I don't think we need to talk too much about that. But carbon is, I think, a little bit new in that the sun does photosynthesis. In the process of photosynthesis, CO2 is pulled out of the air and absorbed through the stomatas of the plants, or the leaves of the plants, and used to make sugar, which also in turn makes cellulose, which makes the wood, which makes the organism, or makes the plant, gives it its physical structure, and creates the sugars that animals need in order to survive. The plant dies, it is broken down, decays, it can become fossils. Also, organisms, it can be in that decaying process, CO2 can be released back into the environment. Also, say from fossil fuels, we use those fossil fuels. We in turn put the CO2 back into the environment, and then the cycle begins again. The CO2 is taken into the plant's leaves, turned back into sugar through photosynthesis, back into cellulose, creates the physical structure of the tree itself, also creates the food for the first level consumers that we talked about earlier. Those are the first 12 concepts for your review here, for your test. It's important that you guys know these different words, and you're going to be responsible for them on the test. So hopefully that helps you, and I will see you guys in class.